Welcome to the Curious Culture Club, where we explore the cutting edge of science and technology. Today, we're diving into the world of fusion energy. Imagine a world where we could harness the same process that powers the sun and the stars, right here on Earth. That's the promise of fusion energy, a potential game changer in the field of clean, sustainable power. Unlike traditional energy sources like fossil fuels, fusion energy doesn't produce harmful greenhouse gases. And unlike nuclear fission, which powers current nuclear reactors, fusion is a process that combines lighter elements to create heavier ones, releasing energy in the process. It's a complex dance of physics that could offer us a near-limitless source of power. But while the potential of fusion energy is immense, it's important to remember that we're still in the early stages of making this revolutionary technology a reality. Fusion energy could be the game changer we've been waiting for, but it's not without its challenges. To understand the significance of fusion energy, we must first grasp its underlying science. Fusion energy, at its core, is about harnessing the power of the stars. It's the same process that lights up the sun and all the other stars in our universe. The basic principles of fusion energy revolve around two light atomic nuclei combining to form a heavier nucleus, releasing a tremendous amount of energy in the process. Now let's dive a little deeper. The real stars of the fusion show are hydrogen isotopes, specifically deuterium and tritium. These isotopes, when heated to extreme temperatures, form a state of matter known as plasma. The plasma is so hot, we're talking about millions of degrees. A heat so intense that atoms can't hold on to their electrons. But how do we contain this super hot plasma? This is where magnetic confinement comes into play. By using powerful magnetic fields, we can trap the plasma in a donut-shaped chamber called a tokamak. The magnetic fields act like an invisible cage, keeping the plasma from touching the walls of the chamber and losing energy. Another method is inertial confinement, where tiny fuel pellets are compressed and heated so quickly that the reaction happens before the fuel has a chance to disperse. This is typically done using high-energy lasers or particle beams, creating conditions ripe for fusion. Despite the complexity of these processes, the outcome is remarkably straightforward. Fusion reactions produce a large amount of energy, more than any other power source we've harnessed so far. And the fuel? It's nearly as abundant as the water in our oceans and the hydrogen in our atmosphere. But it's not just about the energy. Fusion reactions don't produce any greenhouse gases or long-lived radioactive waste, making it a clean and sustainable solution in our search for alternatives to fossil fuels. The science is complex, but the outcome is simple: a potentially limitless source of clean energy. Fusion energy isn't just a theory. Scientists worldwide are actively working towards making it a reality. Today, fusion research is a vibrant field, with teams across the globe striving to harness the power of the stars here on Earth. Recent years have seen notable advancements. For example, the ITER project in France, an international collaboration, is constructing the world's largest tokamak, a device designed to create and contain future fusion power. However, fusion research is not without its hurdles. The primary challenge is achieving a sustained and controlled fusion reaction, something that requires immense pressure and temperatures hotter than the sun. Furthermore, we need to ensure that more energy is produced than consumed in the process, a feat yet to be accomplished. Despite the challenges, the scientific community remains hopeful and committed to unlocking the potential of fusion energy. The benefits of fusion energy are immense, but what does its future hold? This question invites us to dive into the potential of this extraordinary technology to revolutionize our energy landscape. Just imagine a world where our energy needs are met by a clean, practically limitless source of power. Fusion energy, if successfully implemented, could make this dream a reality. It promises an energy supply that is not only abundant, but also environmentally friendly. By harnessing the same process that powers the sun, fusion energy could dramatically reduce our carbon footprint and contribute significantly to mitigating climate change. But the road to making fusion energy a day-to-day reality is paved with challenges. There are still significant milestones to be reached and timelines to be met. The scientific community is hard at work, striving to achieve sustained and controlled fusion reactions, a feat that will mark a significant turning point in our quest for fusion energy. Meanwhile, collaborative efforts and international initiatives are springing up around the globe. These projects, some of which are already showing promising results, are testament to the global commitment towards a fusion-powered future. The fusion race is truly international, with scientists from diverse backgrounds and cultures contributing their expertise to this common goal. Looking forward, the role of fusion in global energy solutions is expected to be pivotal. As we move towards a more sustainable future, fusion energy could potentially play a significant role in powering our cities, industries, and homes. However, it's crucial to remember that the journey towards fusion energy is a marathon, not a sprint. It will require perseverance, ingenuity, and a steadfast commitment to scientific progress. But the potential rewards, a cleaner, more sustainable world, and an energy source that could last for millennia, are undeniably worth the effort. While the road to fusion energy may be long and challenging, its potential to reshape our world is too great to ignore. So let's keep our eyes on the horizon and keep pushing the boundaries of what's possible. After all, the future is as bright as a star if we're brave enough to reach for it.